Okay, final algorithm in this bit on minimum spanning trees is Prim's algorithm again. But this time it's doing it from a matrix rather than from the trees. I think it's quite easy to do from the tree. It's quite easy to look at the points and add them up. Now we're going to do it from a matrix, which I think takes a bit more practice, takes a bit more wrapping your head around. It does do the same thing, but you have to do it in quite a formulaic way. You have to write things specifically to get the marks. So make sure, please, you are following these steps. Again, it lists the steps in the pack for you down at the bottom of page 7. But we're going to go through an example again to help this next one. So these are the steps. Not the matrix. This is the networks that we're going to do Prim's algorithm on, but this time we're doing it from the matrix rather than from the actual network. So you will get the same answer doing it both ways, but sometimes they might ask you to do it from the matrix. Remember the matrix that you get, this thing here, this shows you the connections between the points. So it shows you that there's a arc joining A and B of length 3, there's an arc joining B and C of length 5, and so on. There's dashes in for ones that are not connected up to each. So there are the steps in here which we are going to follow. So you might want a ruler for this one because we're going to be crossing out rows and stuff. Or you might just want to do it freehand, it's up to you. I would recommend pencil in case you do make a mistake, which is possible with these. So the question says, cable company wants to connect 5 villages to the network, which currently extends to the market town of Avonford. What is the minimum length of cable needed? In that question, it's telling us to start at Avonford, starting at A. It will usually tell you again in the question which one to start on, so we're starting at A. So that was step 1 in the steps. Step 2, then it says delete the row in the matrix for the chosen vertex. So I need you to put a line through row A. Okay. I also need you then to label up the column number 1. Label A with a 1 at the top. You need to put that 1 at the top. So that's the first node that you are looking at. Okay, so we're essentially kind of deleting these because they're kind of duplicated. So we're getting rid of these on here. And now we're just looking down column A for the smallest one of those. That's equivalent to you looking at point A and looking for the shortest one that's connected to that. Yeah. Obviously, it's A and B, the 3. So I need you to circle this 3. Let's put a circle around that. And then you're going to do the same again as we did before. You're going to cross out row B. You're going to cross out row B and you're going to label up now column B with a number 2. We're labeling up column B with a number 2 because it's A, B that we chose. If we chose a different letter, it will be a different column that we're labeling up. But B is our second node that we are looking at. So we put a number 2 at the top and you need those numbers at the top. You can also build up your minimum spanning tree as you go along like they've done there. So, underneath, notice we're listing the arcs as we go along. There's a lot going on in here, which I think the matrix one's quite hard. So now we've got nodes A and B in our minimum spanning tree. So now you look down both of these columns, not just column B, you look down A and B for the smallest out of those. Okay. The smallest out of those 2 is this 4 here, so A to E. So you put a circle around that number 4. So we're adding on A to E. So you can add that to your minimum spanning tree. You can add that to your list of arcs. And then we repeat the process. So you cross out row E, you label up column E with a number 3. That's the 3rd node that we have added into our minimum spanning tree. And we keep going again. So now I look at all 3 of these columns. I look at A, I look at B, and I look at E. Out of those ones, I choose the smallest one. What's the smallest one out of those three? The 2. So you put a circle around this 2 here. You're going to add in D to your minimum spanning tree. You're going to add ED onto your list of arcs as you build it up. And we're going to keep going until we've crossed out all of the rows. Our minimum spanning tree is finished. So we're going to cross out D. We're going to label up column D with the number 4 now at the top. And we're looking in all 4 of these rows, these columns now, sorry. What's the smallest one out of those 4 columns? This 4 here, yeah, CD. So put a circle around that one. Add into your diagram CD. So that goes up from D up to C. And add onto your list of arcs either CD or DC. It doesn't matter which order you write those in. We just need to join up F now. So I'm going to cross out the row C. It's got a circle in. I'm going to label up column C with the number 5. And I've just got now this bottom row to look at. Smallest out of those is FE at 5. So I'm going to circle that. Add it onto my minimum spanning tree. Add it onto my list. I am going to cross out this matrix just to this row just to finish it up. So I'm going to cross out row F and I'm going to label up column F with the number 6. And it's easy to want to skip that because you know you've done already, but please make sure you cross every row out. Please make sure you label up every column to make sure you get the marks because they are. Yeah. This one. So for the last one, we've done all 5 of these columns now. We're looking for the smallest out of each of these 5 columns here. All of these rows have been crossed out, so we can't look at any of these other ones. The smallest out of these ones out of this is this 5 here. Yeah. I think this one is less intuitive than the other. The other 2 are quite all right. So just kind of makes sense. This one I think makes less sense. It does do the same thing as Prim's algorithm, just from graph. But there are specific things you've got to label at the top, you've got to cross out on the row. Notice it's fine to circle things in the same column. So we've got 2 in column A and we've got 2 in column E. That's okay. But you will have 1 circle in every row apart from the top one. Not necessarily in every column. Any more questions on principal matrix? In terms of the weight of the minimum spanning tree, so add up these numbers in here. So 3, 4, 2, 4, 5. You get a weight of 18 for the length. There's a little bit underneath about the number of comparisons for this thing. You don't need to go away and learn that. And if you are interested, you can have a look in the textbook for this. But basically, all you need to know is that Prim's algorithm has a order of 3. It's an n cube. So remember we talked about that in the algorithms pack. But if you need this for a question, they'd give you it. So I'm going to quickly whiz through this. Make sure you follow carefully to get something. It didn't actually ask you for the weight of this one, but they usually do. So. First thing, cross out row A. Then you're labeling up column A with the number 1. Have a look down there for the shortest, which is your 134E. Build up minimum spanning tree as you go along and list the arcs as you go along. So now you're looking down column E as well. So label that up with the number 2. What's the shortest out of those? It's this 82 at the bottom here. So circle that one, cross out the row, and add that onto your minimum spanning tree. Now you're labeling up G with the number 3. Look down all 3 of those columns for the shortest, which is the 63. Make sure you check in carefully. It's really easy to miss things. So circle around 63. That adds in F. You're going to label up column F with the number 4. Shortest out of all these 4 columns here, I think, is this 105. Circle that, cross out the row, add it on. Label up column D with the number 5. Shortest out of these 5 columns here is this 110. Even though there are 90s in here, they're not unlocked yet. So there's 110. And then lastly, looking down column C, you add this 90 in here. Your minimum spanning tree, you might have done yours a bit more zigzaggy than this, but they've done it in a straight line. That's fine. Make sure you list the arcs, and it doesn't ask for it, but add up the. It also asks within this question, guys. Shh, thank you. Also ask for the number of comparisons. This is you using the formula from the previous page. It's our n is 7. It's 7 nodes, so you put 7 in there, and you get